Recently I made a kinda cringe video. It's cringe because it I didn't show very many cool 5D shapes and the rotations were really bad, so I'm here in my Godot project that I use just for viewing 4D shapes, and I've imported the 5D stuff. So now, here is our beautiful pentaract. So you can see I can rotate around like this, and it looks pretty normal right now, just your average four-dimensional shape in my renderer. But it actually is a pentaract, and so if I press these buttons, it'll rotate along the global planes, and these are Euler angles, so they will kind of suck, but you can see it's doing like the classic root 2 rotating square bounce, you know? But then what's interesting is when I combine these planes, then we get some interesting behavior. Like, look, this looks like a 6-4 duoprism. Yeah, I mean, that basically is a 6-4 duoprism. Like, I've always thought that one of the pentaract slices is a 6-4 duoprism, but now I have it proven. Look at that. That's a 6-4 duoprism right there. And then I can keep going like this. Look at it go. So cool. And I can also get this other axis going. This other plane going. Look at that. We got some triangular prism cells showing up. Look at that. It is beautiful. That's really cool. Let's see. Is there any other plane? Yep, there's the fourth and final plane. I can rotate like that. Let's get some spinning going on in here too. Yeah. I mean, look at it go. Like, it is so cool, man. Whoever said the fifth dimension was time? Right now, you're seeing 0% of the pentaract because the slice is infinitely thin. Look at it go. So ridiculously awesome, bro. Okay, next what I want to do is check out some other shapes. So I've got 4 shapes here. The next is the hexapteron. And actually, if it has an OFF on the Polytope wiki, you can suggest it to me in the comments, and maybe I'll do another follow-up video, because I wrote an OFF importer, so yeah. Let me just make it a nice blue. Yeah. That's not a nice blue, that's an ugly blue. Okay, there we go. Yeah, so here's our beautiful hexapteron, and right now it looks pretty pentachoral, like, but it's actually a hexapteron. Yo, is that a tetrahedron prism slice? It looks kind of non-uniform, but yeah, I think it is. Look at it go. It's rotating. Yeah. That looks like a tetrahedron prism if I've ever seen one. Oh yeah, that's really tetrahedron prism-like. Let me just rotate around 5D, make it more regular. Or I mean, not regular, but you know what I mean. Look at that. Alright, simplices are kind of boring. I want to make this quick. What else we got? We got the bitruncated pentaract, which is where you cut the edges off instead of the vertices. I'm going to make this yellow. Okay, yeah, so this shape looks a little weird. I forgot. Ooh. Look at it go. Okay, so I'm kind of inside the shape right now. Let me zoom out a bit. There we go. So, yeah, this shape has some kind of funky slices, like that one you saw where it looked like not a full shape. I think that's just a problem with the OFF model, maybe. I'm not sure. Or, I guess it's just because the edges are too long, I think. But right now you can see it just looks kind of like a truncated tesseract. But obviously as I rotate around, you can tell that it's a bit more than that. Wow, look at it go. It's so cool. I fucking love shapes, dude. It's got some triangular prisms, got some rectified cubes, some truncated cubes, some tetrahedra. I know the fifth dimension is really ugly, like objectively, and has no symmetry, but like, it's kind of cool just because it's one more dimension than 4D. Whoa, look at that. Yo. It's so cool. It's like discovering 4D all over again. Wow. I love this, bro. Yeah, so bitruncated pentaract, I think it's my favorite 5D shape that I've seen so far. I haven't seen many. 5D doesn't have a version of the 120 cell because the 120 cell is way too round, which is kind of lame. But, you know, it's kind of 4D's fault, not 5D. It does make 5D a bit of a loser dimension, though. Because it doesn't have an H5 symmetry. If I'm using the notation correctly, feel free to correct me in the comments, because I'm definitely wrong. Because I'm not much of a math dude. And I don't script these videos usually, unless it's like really obvious that I did. Okay, so we got this like truncated rhombic dodecahedron thing, which is kind of expected from a tesseract envelope. Yeah, okay, so I think I'm done with that shape for now. Let's just look at the last one we have, which is the demi-pentaract, which is where you chop, you just like, you take half of the vertices in this way where no two vertices can share an edge. You take half of the vertices of the pentaract where no two vertices can share an edge, and that gives you a 16-pointed shape with 16 cells and pentachora for sides, if I remember correctly. This shape, it's given me, you know what, it's given me a desaturated gray vibe. That's what I'm getting from this shape. Oh yeah, we're really zoomed out from the big shape. So, as grateful as I am for the Polytope Wiki with the OFFs, they do not standardize the size. Like, what I want always, is to have the vertex radius be 1, so it's like the vertices are inscribed on a unit sphere. But for some reason, they care about like edge lengths, I think, for some reason. I don't really understand it. But that means that I have to do some processing on their shapes, on their OFFs, to get it the way I want. So you can see this looks kind of like a rectified tesseract, I think. Because, yeah, this looks like a rectified, this slice is a rectified tesseract, because I can see cuboctahedral cells, and I can see tetrahedral cells. Let's rotate this thing. Okay. Ooh, it's got some funky motion to it. Alright. Let's see if I can get centered on this. What am I looking at here? Okay, so this one's kind of tricky to think about. I see some octahedra and some tetrahedra, which makes sense because we're dealing with pentachora and 16 cells, which, in case you didn't know, the 16 cell has Q octahedral slices sometimes. Okay, yeah, so we just got some octahedra and some tetrahedra. That's what's going on. Yeah, okay. Let's rotate around a bit more irregularly. Okay, things are getting definitely a bit more complex now. Ooh, we got some sort of like, I don't have a name for that shape, but it's like a cuboid with square pyramids on opposing faces. That's cool. That's cool. Okay, yeah, so this is why Euler angles suck ass. You can see right now it's not rotating in 5 dimensions very much because I lost degrees of freedom to fucking gimbal lock every time, bro. Okay, yeah, I'm bored.